Chapter 8, Section 1. Integral as net change. This is a very important section. On page 390, exercise 2, it says v of t, v is for velocity, it's a function of time, equals 6 sine 3t. And the time interval is given. Time is between 0 and pi over 2. So a few things before we read the directions for this exercise. V is velocity. If this is velocity, then the position, this is the velocity in meters per second of a particle moving along the x-axis. This is the velocity in meters per second. So the position, if that's going to be a function of time, has to be the antiderivative of the velocity function of x with some number down here. I'll explain why I'm picking 0 in a second. And the number 3, or the variable t up here, the variable t, s is a function of t. This is where the t belongs. And we're going to have a dx. And we're sticking a plus 3 at the end. So this is coming from my brain, but it's also coming from the directions. And very important that we know why this is correct. This is correct because if we differentiate both sides of this equation, differentiate means take the derivative. The derivative of the left side with respect to time would be the derivative with respect to time of the right side. I'm calling the right side the velocity function of x from 0 to t. So ds dt. S is measured in meters and t is in seconds. Meters up there, seconds down there. This label for this, units for this would be meters per second, so we can call that the velocity function of time. And then by the fundamental theorem of calculus, the derivative of this antiderivative of v of x dx is v of x will exit, and whatever's up here will go in place of the x. And we have this 3 over here, but the derivative of 3 is 0. So since this is true, v of t equals v of t, but also using what I circled up here, using that, s of 0 would mean replace the t, which is the upper limit of the integral, with a 0. S of 0 would be the integral from 0 to 0 of v of x dx plus 3, which follows that s of 0 is equal to 3, because the integral from 0 to 0 of anything is 0, because these terms are the same. And I needed this to be true, s of 0 equals 3. I need that to be true because it is in the directions. That's in the directions. So we're going to start exercise 2 over again. Velocity is a function of t, is given. It's 6 sine 3t. T is between 0 and 2 pi. I mean, t is between 0 and pi over 2. So given this, I know that the position of the particle that's moving is the antiderivative of the velocity, which instead of saying 6 sine 3t, I'm going to call it 6 sine 3x dx from 0 to t plus 3. Because from this, what I just wrote, the given would follow. And also from what I just wrote, s of 0 would equal 3, which is in the directions. So now we're going to make a table. Well, first we have to find when the velocity is 0. And you'll understand why that's important in a bit. The velocity, which is 6 sine 3t, is 0. Divide both sides by 6 when sine 3t equals 0. So I'm supposed to be doing this entire problem without a calculator. So I'm familiar with the sine graph, this is just part of it from 0 to 2 pi. It will continue to the right and left. But from this information, I know that what I'm putting a box around, this right here, 3t, could equal 0, because then this would say sine 0 equals 0, which is true. Or 3t, that's what I have this box around, could equal pi, because if 3t were equal to pi, this would say sine pi equals 0, which is true. Or 3t could equal 2 pi, because if 3t were equal to 2 pi, this would say sine 2 pi equals 0, which is true. There's many more equations I could write even before this. If I solve all of these, 3t equals 0, t equals 0, 3t equals pi, t equals pi over 3, 3t equals 2 pi, t equals 2 pi over 3, etc. But I only care about values of t between 0 and pi over 2. So any t values before 0, not interested in. Any t value after pi over 2. So this one and all the rest we don't care about. We don't care about any value of t bigger than pi over 2. So time to make a table. We're going to make a t column and the position. I think before we complete this table, we're going to figure out a formula for the position. Using this. S of t equals, move the 6 to the left, of the integral of sine 3x dx plus 3. If we let u equal 3x, which is here, and du would equal 3 dx. So I wish that there was a 3 here. I wish this said 3 dx. There we go, 3 dx. That means 1/3 has to be out here. Putting in 3 and 1/3. A 3 there and a 1/3 there. S of t equals 6 times a third, which is 2, integral sine u du, because 3x equals u, and 3 dx equals du. I'm going to erase this. I can pretend I did that in my head. You can't see it, so I did it in my head. S of t equals 2. Well, the integral of sine u du is negative cosine u, so sneaking a negative in there, cosine u. What I mean is S of t equals negative 2 cosine 3x. The thing I erased said that u equals 3x. But this is an integral from 0 to t, like that. That plus 3 at the end just keeps getting brought down. This bracket symbolism means S of t equals, anywhere I see x I'm going to put t, negative cosine 3t, and then minus negative 2 cosine 3 times 0. So S of t equals negative 2 cosine 3t plus 2, cosine of 0 is 1, plus 3. So S of t equals negative 2 cosine 3t plus 5. I need this to complete this table over here. In the table, we're going to put the endpoints of this interval and also the pi over 3. That's a time when the velocity is 0. So the interval starts at 0. We're using pi over 3. Important to know why we're using that. That's the time when the velocity is 0. And we're also going to use pi over 2 because that's where the time interval ends in this question. And that's it. This is another time when the velocity is 0 right here, but that number is not in this interval. Pi over 2 is 90 degrees, and this is more than 90 degrees. When t is 0, look over here where I'm underlining in green, s of t is negative 2 times the cosine of 0, which is 1, plus 5. When t is pi over 3, s, the number for the s column, is negative 2 times the cosine of 3t, we're using pi over 3, plus 5. That means negative 2 times the cosine of pi, plus 5. Let's see, the cosine of pi is negative 1. Cosine pi is negative 1. Negative 2 times negative 1 is 2. 2 plus 5 is 7. And now we plug pi over 2 into this thing underlined over here. Plugging in pi over 2. The position at pi over 2, time pi over 2, is negative 2 cosine 3 times pi over 2 plus 5. 3 times pi over 2 is 3 pi over 2. The cosine of 3 pi over 2 is 0. 0 times negative 2 plus 5 is 5. So here's what this tells you. If this is a line that a particle is walking on, let's say it's the x-axis, at time 0, the particle is, its position, s of t stands for position, its position at time 0 is 3. So wherever 3 is, that's where the particle is starting its journey. That's where it is at time 0. A little while later, this is time passing here, this is the position, 7. So it went from 3 and then it went to 7. And then a little more time goes by, and this is the position right here. So this is not drawn to scale. So it's moving on the line. It starts at 3, goes to 7, and then it goes to 5. It goes from 3 to 7 to 5. This is the journey of something moving on the x-axis. Now that all of this is done, these questions are very easy to answer. Well, all of this was not easy, but the questions are: determine whether the particle is moving to the right. I can see from this little diagram that it's moving to the right in this time interval. It says when, that means it's asking for a time. The time interval is from 0 to pi over 3. Because it moved from 3 to 7 in that time interval. It's moving to the left. When it went from 7 to 5, it was moving to the left, and this was the time interval. The time interval from pi over 3 to pi over 2. And it stopped, well, when it went from 3 to 7, it stopped when it got to 7 so that it could change direction. So it was stopped. Stopped means velocity equals 0. And that was the reason way up here when we said we're going to find when the velocity is 0. Because velocity is 0 meters per second, means you're stopped. And you're stopped at these times right here. Velocity is 0 at these two times. At t equals 0. And also at t equals pi over 3. These are not intervals. These are instants. Part B, find the particle's displacement. Displacement just means, the word displacement means how far is it from where the particle started, that's the red dot, to where it ended up. That's the green dot. We should have used opposite colors there. It started at 3, ultimately it ended up at 5. So the distance between starting point and ending point is 2 units. I guess I could say 2 meters, because they said numbers are in meters. Displacement means distance from starting point to stopping point, no matter how much back and forth was done to get there. Part B also says, what is the particle's final position? And that's in our little table. The end of the time is pi over 2. Its position at the time is 5. The particle's final position is at 5 on the number line. And part C says find the total distance traveled by the particle, T period, D period. So we're going to just look at our little number line here. Let's call this point A and this point B and this point C. From A to B is, how far is it from 3 to 7? That would be 7 minus 3, which is 4. And then the particle went from point B to point C. How far is it from point B to point C? It's from 7 to 5. That would be 7 minus 5, which is 2. How far is never a negative number? From A to B is 4 meters. From B to C is 2 meters. So that means the total distance the particle traveled was 6 meters. And we're done. So I'm going to try to do number 4. Similar method. So here we go. Number 4 says V of t equals 6t squared minus 18t plus 12. The time interval is from 0 seconds to 2 seconds. All right, so we saw it in the previous example. All the directions are the same. We saw that in the previous example, it was important to find out when the velocity is 0, because the particle is stopping when its velocity is 0. If we divide both sides of this equation by 6, we get t squared minus 3t plus 2 equals 0. Then we factor, if possible, t minus 1, t minus 2. That's the same as t squared minus 3t plus 2. So t minus 1 equals 0 when t equals 1, and t minus 2 equals 0 when t equals 2. So this answers one of the questions. These are the times when the velocity is 0. In other words, these are the times when the particle is stopped. Now this is the really important thing right here. The position function of time is the antiderivative of the velocity. And when I write the velocity, I'm going to put x's where the t's are. 6x squared minus 18x plus 12. Put a dx there. The number I'm putting here is a 0 because s of 0 is given. I'm going to put a t up here. I'll re-explain that in a minute. And we're going to put a plus 3 at the end, because this is correct, because if we differentiate both sides of this, take the derivative of both sides of this, you will get exactly this. According to the fundamental theorem of calculus, the derivative of this antiderivative is going to be the integrand, but all x's will exit and t's will go in their place. And the derivative of 3 is 0. And the derivative of s with respect to t is velocity. So like I just said, differentiate both sides of this, you'll get what's given. That's a good thing. Also, if you use this to calculate s of 0, that would mean a 0 would go up here at the top. This would give you that s of 0 equals 3, which it's supposed to be. So this equals, we're going to now integrate. We're going to say 6 integral x squared dx. minus 18 integral x dx plus 12 integral dx. This plus 3 is not part of what's being integrated. This equals 6x cubed over 3 minus 18x squared over 2 plus 12x. No plus c needed. There's a bracket instead. So we're going to reduce these, but also there's a t there and a 0 there. So this means I'm going to reduce these. That's 2x cubed minus 9x squared plus 12x. The bracket that we use instead of the plus c, like that, means replace all the x's with t's. That becomes 2t cubed minus 9t squared plus 12t minus, then replace all these x's with zeros. That'll be 0 minus 0 plus 0. Plus 3 keeps coming down. So we just did a lot of work here to determine that s of t equals 2t cubed minus 9t squared plus 12t plus 3. So when we make a table, in the t column, we're going to use 0 and 2 and 1, because 1 is the time when the velocity is 0. That's why we need the 1. It's when the velocity is 0. 2 also, but I already included 2. So we just use 0, 1, and 2. And we figure out the position at these times. These are the important times. Beginning of interval, end of interval, and the time when the velocity is 0. When t is 0, plug 0 into that, you get 3, which is what we're supposed to get. That's actually given. When t is 1, this will be 2 minus 9 plus 12 plus 3. That's 15, 17, minus 9 is 8. Again, 2 to the third is 8. 8 times 2 is 16. Plugging in 2 squared is 4. 4 times negative 9 is negative 18. I think. 2 times 2 is 4. 4 times 9 is 36. 12 times 2 is 24. We get the plus 3. 16 minus 36 is negative 20. 27 minus 20 is 7. So here's the path. This is the x-axis. A particle is moving on the x-axis. At time 0, the particle is at 3. That's actually given in the directions. Some time goes by, and the particle is at 8. A little more time goes by, and the particle is at 7. So the particle moves from, it goes from, these numbers are positions. S means position. It's at position 3, and then it goes to 8. Then once it gets to 8, it goes to 7. It goes from point A to point B to point C in this time interval. Questions? When is the particle moving to the right? You might want to say it's moving to the right from 3 to 8. But that's not correct. It's moving to the right in this time interval, 0 to 1. When is the particle moving to the left? Someone might say it's moving to the left from 8 to 7. That's not the time. It's moving to the left. It goes from 8 to 7 in this time interval. 1 to 2. And when is the particle stopped? We answered that at the beginning. When the velocity is 0, that's when the particle is stopped. When the velocity is 0, that's at these two times, t equals 1 and t equals 2. T equals 1, t equals 2. So that's part A. Part B, Find the particle's displacement. The word displacement means how far is it from the starting position to the ultimate ending position. Started at 3, ended at 7. How far is it from where it started to where it ended? It's the distance between 3 and 7, which is 7 minus 3. And what is the particle's final position? That's right in the table directly at the end of the time interval. This is its position. That's its final position, 7. I think the 4 should be labeled meters. Part C, asking for the total distance. So I just look and see how far is it from A to B. From point A to point B is how far? From 3 to 8. That's 8 minus 3. And then when it went from B to point C. How far is it from B to C? That's from 8 to 7. 8 minus 7. It's 1 unit. These distances are never negative. So the total distance the particle traveled to get from A to B to C is 6 meters. 5 meters plus 1 meter. That's it. So now we're going to try to do number 20. This time there's a picture given in the textbook. It has a whole bunch of line segments connected. Like this, and like this, and like this. This, the x-axis is actually the time axis in seconds. The y-axis is actually the v-axis in meters per second. And you should look in your book to see the numbers that are here. I'll just tell you this is obviously 0 and this is 10 over here. These shapes here, there's a triangle up here, there's a trapezoid down here, and there's another triangle here. The areas of these, the area of the triangle up here is 3, the area of this trapezoid is 12. The area is never a negative number, and the area of this triangle up here is 4.5. In the directions, it says the particle starts at x equals 2 when t equals 0. That's telling you the position of the particle at this time, 0, is 2. Is the particle moving on the x-axis, not this axis. It says the velocity is given. So here's the important thing that we used in the previous two. The position as a function of time is the integral of the velocity, which we'll call a function of x, dx. And I'm putting a 0 at the bottom because the initial condition has a 0 in here. And I'm putting a t up here because I want s to be a function of t. That's what the t is. And we're going to throw a plus 2 on here to make this satisfied. S of 0 has to be 2. And the derivative of s, position, has to equal velocity. S, the derivative of s of t should equal v of t. That's actually the definition of velocity. It's the derivative of s of t. So that's just like what we did in the last two problems. Now, what we're supposed to be doing here is finding where the particle is at the end of the trip. That would mean here's the end of the trip. 10 seconds is the end of the trip. And the total distance traveled by the particle. So just like the last problem, we're going to make a column with t and s of t. And in the time column, we're going to put the 0 and the 10 because the trip starts at time 0 and ends at time 10. But we're also going to put the times when the velocity, this is a picture of the velocity, is 0. And you can see in the text that this is 2 is a time when the velocity is 0. And so is 7. And so is 10, but we would use 10 anyway because it's the end of the trip. So we're using 0, 2, 7, and 10 in the time column. Once we have all these, we'll map out a little journey on the x-axis, and everything will get answered. S of 0 means put this 0 right there. It'll be the integral from 0 to 0 plus 2, so it's 2. It's good that S of 0 is 2, because that's actually given. S of 2 means the integral from 0 to 2. This 2 is going to go where the t is. So integrating this function here from 0 to 2, we get 3. That's 3, but don't forget to add the 2. Putting a 7 where the t is. Putting a 7 where the t is. The integral from 0 to 7 of the velocity. The velocity means the blue picture there. The integral from 0 to 7. The integral from 0 to 7 is 3 minus 12. Got that? This integral from 0 to 7 is 3 minus 12. Don't forget the plus 2 there. That means 5 minus 12, which is negative 7. Then put a 10 where the t is. Put a 10 where the t is. The integral of the velocity from 0 to 10. Don't forget that at the end. The integral from 0 to 10 of the velocity graph is 3 minus 12 plus 4.5. The integral of this function from 0 to 10 is 3 minus 12 plus 4.5. Don't forget the plus 2 at the end. That's 7, 8, 9. 9.5 minus 12 is negative 2.5. All right, so this is enough information for me to do this. Here's the x-axis that a particle is moving along. Particle is moving on the x-axis. At the beginning of time, time 0, its position is 2. Then it moves to 5. Then from there it moves to negative 7, which is way over here somewhere. And then from negative 7 it moves to negative 2.5. So it goes from point A, starting point, to point B, and from point B it goes to point C, and then from C it goes to D. So it goes from A to B to C to D, A to B to C to D. And the question is, where is the particle at the end of the trip? Right there, negative 2.5. Part B, find the total distance traveled by the particle. So all we got to do is figure out how far it is from A to B, and then how far it is from B to C, and then how far it is from C to D. The how fars are never negative numbers. From A to B, 2 to 5 is 5 minus 2. From B to C, that's from 5 to negative 7, is 5 minus negative 7, which is 12. And then from C to D, it's from negative 7 to negative 2.5. That means negative 2.5 minus negative 7, which is 4.5. So the total distance from A to B to C to D, total distance, is 19.5 meters. That's it. And I think that's it, except I do want to mention a couple of shortcuts that you could use if you were allowed to use a calculator. Those were all done without a calculator. You have to know how to answer these without a calculator. When a calculator is allowed, you can use these shortcuts. Displacement will always be the integral of the velocity from some time to some time. And total distance will always be the integral of the absolute value of the velocity from some time to some time. So we'll talk about these shortcuts in class because period 11 is entering the room now.